Thank you for joining. Welcome to the Blu Room. We still have people coming on, but our commitment to you is that we start at 10:30. Content is being delivered from 10:30 to 11:15. And we have questions for those who want to stick around from 11:15 to 10:30. We know you guys are busy, so we're literally going to push through. And as the other guys join, we welcome them on and keep the content moving. Thank you for the time, the interest. Welcome to the Blu Room. All right, let's move on, guys. From a housekeeping perspective, webinar is 45 minutes, Q&A with 15 minutes. Questions will be submitted via chat during the webinar. I have somebody from my team actually collating the questions. So once we get the questions, we could come back to them at 11:15 to 11:30. If we don't answer all questions, then we'll definitely get back to you via email and so on after the webinar. All questions will be pooled, right, as I just mentioned. The webinar is being recorded. All right, so let's go, guys. Thank you for joining. On today's webinar, we actually have two guest presenters. We have Jorge Hortensio Parra from Ruckus Wireless. Jorge is the territorial account manager for Ruckus. And we also have Eric Hernandez. Eric is an systems engineer from Ruckus Wireless. So Jorge will actually bring a commercial perspective as well as a global perspective based on his territories and so on, what we experience in, while negotiating the wireless opportunity with the customer. Eric, being on the implementation and engineering design side, Eric would actually bring the experience, again, from a global perspective, what he's seen out there, what has he experienced, etc. Again, my name is Sheldon Paul. I'm the Director of Engineering and New Business for Blu Networks. I work on both the implementation and commercial side, so I will bring that experience as well. The goal here is to highlight some of the issues that we've seen outside in the environment that contribute to some of the problems that customers complain about. We can have Jorge, you can jump in and introduce yourself, followed by Eric. Morning.
Absolutely. Good morning. Thank you, Sheldon, for the invitation. Good morning, everyone in Trinidad and other islands in the Caribbean. My name is Jorge Atencio. I'm the territory account manager from Ruckus and based in Miami, Florida. And from here, I'm managing all the Caribbean territory and also all Central America. Been having the opportunity in the wireless industry and the networking industry for already 11 years, and having a great opportunity in the territory to also work with the hospitality vertical, private sector, government, and education. So please, whatever I can bring to this conversation, it will be a pleasure to help, absolutely.
Morning, Eric.
Hello, good morning, everyone. My name is Eric Hernandez, and I'm a pre-sales system engineer at Ruckus Networks. And I've been working for 5 years in Ruckus, working with service provider market and enterprise verticals like hospitality, retails, warehouse, education. And I'm here to have a good conversation.
Thank you. All right, guys. Staying connected with Wi-Fi. I just want to see by a show before we push forward, somebody can just unmute their mics and make sure that they can actually see the screen and everybody's hearing us properly. All right, good.
Yes, hearing you.
Great. So staying connected with Wi-Fi, guys. Why this topic? Blu Networks has been involved in Wi-Fi for the existence of the organization, which this year would be 7 years. So we've seen a lot of, I want to use the word issues because we like to understand customer issues and talk about how those issues can be addressed. So we've seen in Wi-Fi networks common problems, and these problems are normally associated with staying connected because every Wi-Fi device can actually connect a user. The challenge with Wi-Fi devices now is staying connected, designing networks to sustain connectivity, right? And the webinar is actually geared to have you guys understand some of the, not all, but some of the challenges that contribute to those problems because Wi-Fi has grown in popularity. Wi-Fi will continue to be one of the most popular technologies in many years to come. It's being used worldwide. So we respect the technology, we learn it, we understand it, and we see it only fair to work with our customers and potential customers to do the same. So staying connected, take it literally, guys. You want to talk about some of the issues that create situations where customers are not, consistently or connected on their Wi-Fi network. From an agenda perspective, what we're going to do is look some of those issues. The issues are actually listed here, and we're going to look at them. I wouldn't run through all because we'll go through them one by one. So we'll follow on from wireless side service straight on the polarization diversity. All right, so let's jump straight in. I have to keep myself on time because, we want to keep this at 45 minutes. All right, wireless site survey, guys. What is a wireless site survey? Why are we speaking about wireless site surveys? Why should it be done? Why is it important? Just being brief, a wireless survey at the end of the day, guys, that's a series of activities that are executed to bring the requirements necessary to deliver the solution. What are those activities? We've seen a lot of times in customer installations, wireless surveys not done. And if they're done, they're not done properly. And properly is relative to where you are coming from a point of knowledge. And at Blu Networks, we take it very seriously. Every solution that we implement wireless related, a survey must be done, regardless of how small it is. So, we'll discuss wireless surveys today, but before we get into it, Jorge, have you seen situations out there in your territories where this step is neglected?
Yeah, actually, it's very common for some of our customers in the territory that they do not really take into consideration a site survey. And site survey, I think, is one of the key factors to really complete customer expectations in terms of wireless connectivity. Why? Because sometimes we have find some customers looking to have Wi-Fi, and there is, I would say, there is a belief that you only connect a wireless router or you connect an access point and pretty much voila, you're all set. You should have Wi-Fi all over the house or all over the office or all over the building. But that's not the reality.
Correct.
The reality is that Wi-Fi uses, of course, the wireless technology to spread the signal, but there are a lot of factors that we have to consider, such as construction materials, ceiling heights, if there is any glass or any body of water or any other object in the environment that can affect the Wi-Fi development. So it is very important to understand customer needs in order to deploy a really good site survey. So yes, we have seen, and there is a very nice example of a customer that was complaining about Wi-Fi, and pretty much the APs or the access points were located next to a glass wall. And as you know, glass is one of the enemies #1 of Wi-Fi. So when you prepare a design with a site survey, you know that you cannot locate an AP so close to a glass wall, because of course you're going to have issues with the connectivity. So it is very important, and we see in the territory some customers complaining about having wireless issues, and one of the main problems is because they didn't have a design like this.
Okay, and thanks, Jorge. And guys, what are these activities that we're talking about? There are 3 types of wireless surveys: predictive, passive, and adaptive wireless surveys. The passive wireless survey is essentially when you walk through an environment and you just fill your head with requirements. You check some of the constructions, etc. The predictive wireless surveys are actually when you use applications and you input the construction material, and that helps generate the area of propagation, and you understand where these access points are placed, right? Now, the active wireless surveys are wireless surveys where you use actual equipment. We use actual equipment. We use the actual access points, and we measure actual signal strength based on certain variables. Now, and Eric, I'm coming to you with some questions now. A wireless survey from where we sit should include throughput testing, which is understanding the value in terms of throughput that you will get from the user or client to the access point. And this should in itself be tied to the requirements of the application. It should include an understanding of the intended use of the application, which we will go into. It should include a spectrum analysis or an understanding of what else is on the RF platform, what other access points, what other channels are used, which we'll go into as well in other slides. And it should include a diagram of the intended location or site, and you walk through that diagram while doing your survey. Now, quickly, Eric, from a technical implementation perspective, what are some of the issues, not to go into too much because we come to those slides in a few seconds. What do you see in your areas when doing this implementation with respect to the, not respecting the need for a wireless survey and so on?
Yeah, the best way to understand the importance of good design is to consider the problems that occur because of bad design, or even worse, if you don't perform a site survey. The problems with a bad design are poor performance, insufficient coverage, and insufficient capacity, right? You can use a software tools like we see in the slide in order to simulate the RF propagation based in blueprints and propose a proper location of APs. But this not enough in the most cases, because the best way is to perform a site survey in the site, right? It's important to take note that the way in which the RF wave moves, it's mean the wave propagation, because it's depending of materials like Jorge mentioned. If we have in the site drywalls, metal, or glasses tinted glasses that Jorge mentioned, all these type of materials could affect the wave propagation or attenuate the signal strength. And these factors have a problems with the performance around our applications or our devices. In some cases, the best recommendation is to have a value for RSSI a minus 65, because now actually we work with our smartphones that have smallest antennas. So that's the best recommendation about the signal strength.
Okay. Right. Okay. And we'll get in, thanks Eric, we'll get into RSSI and so on as we move further. Running straight into, again, understanding the environment, guys. So a wireless survey is just one point of it, and we see these things neglected. We also need to understand the purpose and application usage. Similar to an architect building a building. That architect needs to understand, what am I constructing this building for? What is going to be, what is the purpose of this construction before they build? It's the same concept, guys, that we have to employ when looking at wireless networks. What type of data will be used on the network? Would it be voice data or both? We have some clients still thinking that data is the same as voice and video. Theoretically, probably, but in terms of load and requirements, that's a whole different ballgame, right? In the first slide, when we spoke about throughput testing as part of a wireless survey, throughput testing for data is different to throughput testing for voice or throughput testing for internet browsing. Internet browsing, average throughput may be 5 meg. Voice, maybe 20 meg. So you're looking at 4 times the required, at least 5 times the required throughput. So taking into consideration the applications that are being used, how many users that are on the network, what is the target throughput, those things are critical when doing a wireless survey. So it's no easy task, but it should be done. You should understand the purpose. Jorge, you have anything you need to add here?
Yes, absolutely. Actually, I was remembering some of the cases, right, where customers do not understand the usage of a network. And I think this is very important, because sometimes some customers have the expectations that just because I have the Wi-Fi solution, it's okay for video, for data, for voice, or for any other, including a streaming of video, checking video camera surveillance systems, and not necessarily the same wireless solution will work for everything you are expecting for if you did not consider it at the moment of the design. So it's very important, especially in the private and government sector. Sometimes they expect the regular Wi-Fi to also be used for security and so many other things. And it's okay, it can work, you can have it. But please, it's important to consider it since day one, so you make sure your wireless solution will be capable to support all the applications you're expecting to use. So yes, it's very, very important, and it's a very frustration breaking point in some customers around the territory for sure.
So briefly, guys, now let me be devil's advocate. We've been deploying wireless for a while, and we've had these questions come to us. For instance, why should I care? Why should the customer care about what is being transported on their network? Okay, this is just a practical situation. I've just spent money on what they think is the best platform, right? The requirements were I need to browse the internet. But all of a sudden I end up on a Skype call, or I end up on a web page that has video embedded, and the 50 users that I expect the platform for have poor performance. I mean, so what I'm trying to get at is that not understanding the purpose even has implications on the actual design for the number of access points. If I'm designing for voice, the requirement for voice is totally different for data in terms of the number of access points. For example, you have access points rated at 250 users per antenna. But when you read the fine print, 40 for voice. So there are drastic differences. And Eric, I know you've seen this in some of your deployments where the requirements are for browsing, but browsing is not the same as it used to be. You have video embedded in pages and so on. So you essentially, from where we sit, should be catering for voice or similar type technologies, not just data. Any comments there?
Yeah, application adds an extra layer of complexity in the network. Some applications require massive amounts of throughput, like a data transfer, yeah? While others require a little. Some applications require a great speed in delivery or latency sensitive. This is the case for voice or video over IP, yeah? That is different like data transfer. The requirement is totally different. For example, in warehouse is not important the latency, okay? Even in these cases, the most important is the coverage and to have a good solution for data transfer, but in small data transfer. But in other cases, the speed is the requirement, right?
Correct.
So understanding this application is the key in all the designs.
Okay, thanks, Eric. And of similar importance, guys, is the number of clients. I can't stress, or we can't stress how important this is. And what's key is that the first question on the slide, what is meant by the number of clients? It is not the number of people. A client, theoretically, is a device that connects to our network. So by definition, anything that connects to the wireless network is considered a client. Now the proliferation of cell phones or devices per user is nothing less than 3. Some people have tablets, laptops, cell phones, probably 2 cell phones. You're already at 4 devices. So when considering the number of clients, guys, make no mistakes. Considering one user alone, that may be a drastic mistake. Consider everything that has to touch this wireless network. Smartphones. Sometimes people have smartwatches that they connect to your Wi-Fi. You may not know about. The point is, anything that touches that network should be considered. And these things also affect the overall performance. For instance, you have devices, you have networks that are designed, when even doing your site survey, you design a network or an AP cell. An AP cell theoretically is the coverage area for an access point. And within that coverage area, because wireless is shared, it's a shared mechanism, it's shared bandwidth, you actually have to cater for the amount of users within that cell. If you don't take into consideration the amount of people that are going to connect to that AP, you're not designing a solution to sustain the overall complement, because you may think 100 people, but 50 people sit in one room. And as far as you understand, those 50 people are going to be, dealt with that access point, but you have rooms that have no people in it. So, I mean, it makes a lot of sense, and it can mean you spending more money if these things are not taken into consideration. Eric, can the number of clients influence the access point quantity? I mean, we've just said yes, but give the clientele an example. Where have you seen a situation where they don't consider the amount of people, and after the deployment they have issues?
Yeah, anytime. In the data sheet of the APs for another vendors, including Rocos, we can see how many clients per AP. Yeah, other vendors make a 100, 200, 500, but in the reality is not in fact, right? Because it's depending about the design, it's depending about the authentication of the network that we can deploy, the number of the clients per IP. Yeah, when we talk about high capacity, I mean design maybe for stadiums, convention centers, meeting rooms, or public venues, it's important to find a technology that offers a great capacity, connection stability, and good performance. But remember, the design for density is different than the coverage design. And for this type of cases, don't forget about the LAN in the wireless LAN. I mean, for all the resources like switches, routers, firewalls, or DHCP servers, or backend systems like radio servers or captive portals, because all these elements, they must be prepared for the number of the devices in the network. This is another problem when you design for high density users.
Right, and guys, to add to what Eric is saying, guys, designing for high density is totally different to designing for the traditional enterprise network, right? But the point is, whatever you're designing for, you have to consider the number of users, the number of devices, everything we've spoken about so far, right? We're stressing on them because it's very important, and these are some of the factors that are neglected, and these things contribute to 90% of the problems that we're seeing with people out there, right? Let's jump into frequency and channels. We have questions like, what is a frequency and what is a channel? So let's dive into it, guys. Taking into consideration this photo of a highway, right? The frequencies can be considered as the actual highways. So whatever you transport on a wireless network has to be transported on a frequency, right? And those frequencies are actually given out. You can't just create your own frequency. They're managed and they're monitored worldwide. So frequencies are similar to highways, right? The data passes on the actual highway. Within Wi-Fi though, and we'll get into channels in a bit, within Wi-Fi, there are actually two frequencies used, 2.4 gigahertz and 5 gigahertz. And again, what's the difference? Let's look at the photos here. We tend to use photos because we don't want to kill you with PowerPoint slides. So we tend to use photos, right? So if you look at the photo on the left, that looks like, the guys from Trinidad could understand this if you're coming from south to Port of Spain in the morning, all right? That looks ridiculous. The 2.4 gigahertz frequency, guys, is a saturated frequency, right? It's very congested, and I mean, everybody uses it. But this is essentially what the 2.4 gigahertz frequency could be symbolized by. On the right, you have the 5 gigahertz frequency, which is a cleaner frequency, right? And we'll talk about why this frequency is cleaner as opposed to the 2.4. So in summary, the 2.4 gigahertz frequency can be seen as the frequency, the photo on the left, where you have a lot of traffic, and the 5 gigahertz on the right. Now, some of the pros and cons of the 2.4 gigahertz frequency. The range of the 2.4 gigahertz frequency is further reaching. Now, theoretically, in frequency spaces, the smaller the number, the further reaching the actual frequency. What that means is that if you have an access point on the 2.4 gigahertz frequency, you'll find that access point reaches further with signals through walls and so on. It's less susceptible to interference through walls and so on because it's a further reaching frequency. The 5 gigahertz it doesn't reach that far, not to be seen as inferior though, guys, right? As we'll see. The cost of the 2.4 gigahertz frequency and technologies associated with 2.4 gigahertz frequency are normally cheaper because it's legacy type frequencies. The 5 gigahertz frequency now, the technologies are normally more expensive. Take, for instance, the difference between the brand new iPhone and some of the inferior phones. I don't want to call any brands here, but a lot of the times that's because of the antenna and additional technologies within those phones. The new iPhones and so on are dual band phones. So you find that, you know, for guys that didn't know, those things contribute to the price because these phones can actually see on both frequencies. Now, the cons, the 2.4 gigahertz frequency has less channels, which we'll see in the slides that follow, right? The 2.4 gigahertz frequency has less channels, hence the reasons for all the traffic. The 5 gigahertz frequency has more channel spacing. So when we talk about frequencies, the frequencies are considered the highways, the channels can be considered the lanes on the highways, right? Now, Jorge, based on your territories and so on, the proliferation of the use of the 5 gigahertz frequency to the 2.4, are you seeing that wider usage of the 5 gigahertz than the 2.4 based on the traffic saturation and so on?
Yes, and it's a fact, and thank you that you mentioned about mobile devices and the dual band technology that pretty much all the new, I don't want to use the word high-end, but pretty much all the new high-tech oriented devices are coming with the dual band, because maybe some of the people here in the audience, we pretty much all of us, we have a microwave at home, we have maybe some cordless phones, maybe our kids are using remote car controllers and so many other things that, guess what, uses 2.4 right? So that's one of the reasons why the 2.4 frequency is so saturated. So, and also some video surveillance. We have seen in stadiums and public venues how communications or voice devices are used in 2.4. So this is something about letting people know that dual band devices will help you to choose between the saturated highway on your left or have the option to navigate through the 5 gigahertz frequency, which is a little bit not that busy as 2.4. However, there is a big proliferation of users moving or getting devices that now supports 5 gigahertz. So I don't think this is going to be for too long to have these differences between 2.4 and 5. The good news is that there are new frequencies coming pretty soon in the wireless industry, and Ruckus is working on it. So hopefully by the end of this year, we might come and announce new frequencies that will be available. So guys, pretty much is, instead of the highway on the left or the highway on the right, there is a new super duper highway coming into the world for the wireless infrastructure, and should be announced in October this year.
Great, that's excellent news, because we see the 5 gigahertz frequency being heavily saturated when we do deployments here now. And you brought up a good point, Jorge, just before we move from this slide. Guys, you in the audience, you all should not be considering any wireless platform that is not dual band. If you don't know how to check it, give us a call, send us an email. We will check it for you. Anything that operates on the 2.4 gigahertz frequency alone should not be purchased. don't make that decision, right? You would actually not future-proof the organization. And I mean, you're opening yourself to just the use of a saturated platform. So dual band should be the standard for any wireless solution, at least until the additional technologies come to pass. All right, moving right on, guys. Channel usage and interference. Now, this topic is huge. We'll start by what is a channel. We actually spoke about that briefly before. So the highways are the frequencies, the channels are actually the lanes on the highways. We spoke about the difference in 2.4 and 5 gigahertz. Well, because the Wi-Fi frequencies are regulated across different countries. So right now in Trinidad, I think we have 11 frequencies on the 2.4 and about 24 to 25 on the 5 gigahertz. Eric, that sounds correct, right?
Yeah, we have in 5G 23, but actually when 11AC standard comes to the world, we increment to 25.
All right, good. And so understand the difference, guys. 11 versus 23 or 25. The 2.4 gigahertz frequency is almost half the channel capacity of the 5 frequency. And this is without getting into additional technologies like how wide is your channel and how much data you're going to support. So how does the channel play into the overall solution? An access point and the client communicates together during a Wi-Fi transaction. Your device connects to an access point, and that has to happen on a channel which sits on a frequency. So if your mobile phone, and we use mobile phones as examples a lot because, believe it or not, that is actually proliferating far more than actual laptops and so on. If a mobile phone connects to an access point, it is done on a channel. They have to negotiate and they connect, but it is done on a channel. So if you have a lot of people on the same channel, right? Because of the fact that Wi-Fi technology is not Ethernet switch technology, guys, meaning it is shared. If you have 50 people sharing the same channel space on an access point, these people cannot talk at the same time. No one device, no multiple devices transmit data at the same time. You have something called a channel assessment. So if you pick up your mobile phone and your mobile phone has to transmit data, that has to listen, determine whether anybody else is transmitting, and then transmit. If you have to do that for 50 people on one access point, and everybody has to do that 300 times in a minute, these things happen. This happens at the speed of light. That's what goes on behind the scenes. So the point I'm making is that channel usage, channel capacity, and planning of that channel within your Wi-Fi design is critical to the overall capability for data transfer. Right? I'll jump to the next slide where we get a little technical, where we show you when we talk about channels, what are we speaking about? Now, if you look at left to right, you see the blue curves. All right? Let me get these blue curves. Those are actual channels. All the curves are actually channels. But what I want you to actually see is the amount of channels straight. This is the 2.4 gigahertz frequency. So every access point and client that has to communicate has to use one of these guys, a channel. Right? So every client sits on a channel. So the more channels on our actual Wi-Fi network creates more capacity. So it's very critical, right? Eric, I want us to give them just a taste of channel spacing, 20 megahertz versus 802.11 AC, 40 and 80 megahertz, and the impact on overall data transfer, just before we move from this slide.
Yeah, as you said, and it's very important that many people doesn't know about the Wi-Fi, that the Wi-Fi use a shared medium, as you said. This means a user send information when no one else is sending, just one at a time. And that's why the channel are shared with all the devices. So if you have a network with all the devices connected in the same channel, And exists another AP, a neighbor AP using the same channel. We share the same channel, even when the AP is another one, because we use the same spectrum. So we can have a saturation about this channel, and we can have a performance problems, retransmissions with the devices, and we have to work, it's difficult to work in order to have an overlapping these channels. And another factors is that the no Wi-Fi devices use the same spectrum. For example, microwave ovens use all the channels, right? So if you start working with microwave ovens, you start to use the complete spectrum into the 4 band. Bluetooth devices use another type of modulation that instead to use one curve in the channel, they use all the channels, but with different power levels.
Sort of like channel bonding.
Yeah.
And thanks, Eric. And just to leave you with this, guys. I actually lost my train of thought there. Yeah, it is critical that we understand that when you have Wi-Fi platforms promising bandwidth capability, you have to do your homework. Some of these guys promise bandwidth capability by bonding multiple channels on like the 2.4 gigahertz frequency. So sometimes you deliver, let's say 300 meg, and you have to combine 2 channels. But you're already in a saturated space, and make no mistakes, guys. You are in one building, the tenant next door has an access point. They are not using a separate spectrum. You're on the same spectrum. 2.4 gigahertz in your office is the same 2.4 gigahertz in the other user's office. So we need to be careful, and all of this is picked up in a wireless survey. In terms of co-channel interference, guys, interference is very, very, very key in any wireless network. Interference, those are the actual radio frequencies and so on that actually, compete for space within the spectrum. As Eric mentioned, the microwave ovens, the Bluetooth devices, these things compete for space. From an interference perspective, you normally have 3 types of interference. Co-channel interference, this is where every client and access point, they operate on the same channel and they compete for time to talk. So within the example where we spoke about 300 people in a room, or 200 people in a room, 1 access point or 2 access point. The point is, at some point in time, they're going to be competing for channel space. That is co-channel interference. Adjacent channel interference speaks to channels that overlap. So if you look at the blue lines to your left, there are some other colors. Those are other channels, but those channels overlap or enter into another channel space. Remember, each channel is a lane. So it's like you have a traffic warden on one side of the highway and another traffic warden on the other side of the highway, but that traffic warden has to direct traffic on this side of the highway and on the other side of the highway. That's not possible. So you have data corruption. That's critical as well. And non-Wi-Fi interference speaks to the microwave phones, the Bluetooth devices. The point is, the spectrum is the spectrum. You are not alone on it. So when doing your surveys and so on, you have to take all these things into consideration. We spoke about this already. Just to drive the point home, some of the causes of co-channel interference are the neighboring access points. Too many access points in a building, guys, that is not necessarily the best thing. Please. Sometimes you could deliver the result with 5 access points as opposed to 8. Survey is important. Wi-Fi clients, these Wi-Fi clients emit RF energy as well. So more clients create more energy, which creates more interference. Mm-hmm. And it all results in service degradation, high response times, business affecting type scenarios. And there are different ways, and we could always talk about these ways when we get into, our private calls and so on if you want to. But proper channel plan, site survey, guys, managing the access point power levels, which is normally done from a controller perspective, but you need to consider them from a design perspective, and a solid roaming plan. Roaming plan meaning how do we move from one access point to the next? No organization or no enterprise has one access points. These access points actually deploy solutions with multiple access points, and you need to manage and design how do I move from one to the next. Polarization diversity, guys, we're almost at 11:15. All right, so I'm trying to manage my time. What is polarization at the end of the day? You ever notice that when you get up or when you move around with your mobile phone or your tablet in your hand, you change the orientation of the device? At the end of the day, polarization speaks to the way that the RF signals are actually emitted from the antennas. So polarization, if we look at the middle of the screen, polarization can either be horizontal or vertical polarization. The point is that each device emits RF signals in a particular orientation. If this orientation of the actual sender and receiver is not aligned, you have data loss. That happens as we speak. You pick up a phone, you turn it around, you put it in your pocket, you walk around the wall, your signal strength drops. It can be as a result of polarization. So misalignment in polarity is something critical. And when you're designing a Wi-Fi network, you have to take into consideration not only how much clients. Are my clients laptops? Right? Laptops actually are designed with the antennas in the actual screens, right? For vertical polarization, right? So when that happens, you know, a lot of the times when you install access points, you install them at a horizontal level. So the polarization is such that the laptops will be fine. But when you take mobile clients out, tablets, and you change the orientation, which they're designed for, that creates misalignment in polarity. Now, there are different technologies to address that misalignment, like polarization diversity, right? And I know Jorge and those guys would start to smile just now, right? And there are also things to take into consideration, guys. Some people address signal strength and so on by using more access points or access points with higher antennas. Showing more RF or more antennas behind a wireless network is not necessarily the best thing, right? Try listening better. It's like we're having a conversation. If I can't hear you, I can't understand you. You could talk as loud as you want. If I'm not listening, it makes no sense. So work with access points that can listen better, that employ technologies like polarization diversity. Jorge, what do you have to say about PDMRC, polarization diversity?
Yeah, well, I know we have like 2 minutes or so, but it's very interesting that there are some bunch of investigations about polarization, but you can lose, just the audience will not believe it, but you can lose an average of 40% of performance just because of polarization. Okay, there are some access points that are designed to work on devices like laptops, right? Like flat. But when you have mobile devices, you have phones, or you have tablets, and you can move them all around. If you are not on the same orientation of antenna, you can lose up to 40% of performance. And this is key, especially when you have kids 2-3 years old and they want to keep running Netflix on their tablet. They expect Netflix to be running. Doesn't matter if they are on the bed or if they're on the couch or whatever they are expecting for the wireless connectivity to keep and perform well. So this is a very important thing. 40% is a lot.
Agreed. That's almost half antenna, about -3 dBi. That's almost half the power of the antenna. All right, guys. 11:15, 11:14, and about 30 seconds. So I think we managed the time properly. Thanks, Jorge, Eric. All right, we can jump right into the Q&A. Let me see.
Thank you.
If I have any questions. An email. I don't have any questions in email yet. Let me check the chat. So I have will the event be recorded? Yes, it is being recorded. So don't worry, Terry, you'll be fine. What applications are more suited to 2.4 versus 5 gigahertz and vice versa? Well, how to put it? The application itself, and I mean, I'll let Hoy and those guys and Eric chime in. The applications themselves will have requirements. Take, for instance, voice versus video and so on. So from where I sit and from my understanding and what we've seen out there, application requirements are not normally tied to frequencies, but what can be determined, what you can use to determine the frequency you use would be what you want to achieve from the application. For example, if you have voice is latency sensitive. Now the 2.4 gigahertz frequency can carry voice, it can. But based on your present situation within the space that you're in, RF space that is, because of the saturation, it may make more sense based on your throughput testing and so on to carry that to the 5 gigahertz frequency just for that increased clarity and increased performance. So from where I sit, David, I've never seen a requirement from an application for a frequency, but more a requirement for a throughput, which you can tie to a frequency based on frequency performance. Eric or Jorge, how do you feel about that question?
Yeah, you're absolutely right. The application is not about which frequency do you use. It's about the requirements, about the latency sensitive or another type of requirement, right? We talk about that the pros and cons about the frequencies. So maybe you can define it if you see in your environment that the 2.4 band is more crowd, probably you want to use only 5 gig for your application, but it depends. It not depends about the frequency.
Okay.
I would like to add into the 2.4 and 5, and sorry to interrupt, is it's also, yeah, as you guys both mentioned, there is not an application with a specific frequency requirements. However, it has to be a lot with expectations. For example, when you want to use Wi-Fi for content that demands a lot of throughput, right? For example, 4K content. Now 4K on a streaming video, it's been very popular on many platforms, right? There is the new Amazon Fire Stick using 4K, the new Apple TV uses 4K, and also for gamers. I don't know if there are any gamers on the on the session, but also now gaming, the PlayStation Pro and all the new TV video consoles uses 4K content. So even security. There are now every security wireless solution that you can buy for home or a small business uses HD. So for that type of application, I will personally recommend to go through 5 because of what you just have discussed, right? You have more bandwidth, you have more channels to drive all that traffic back and forth. So at the end is what your expectation is, right? If you're expecting to have really clear, neat video and so on, I will recommend 5 gigahertz. And if it's more data that any delay might not affect your experience, right, as a user, then 2.4 is fine. But also we cannot forget the bandwidth we are getting from the service provider. And this is something that I think we should keep in mind is, even though you have 2.4 and 5, yes, 5 is faster, you have more channels, you have more options to get a better throughput. But if the service that you're getting from your internet service provider is not, let's say, fast enough, you will still having issues. So this is very important. Sometimes it's a combination of the hardware you have for wireless, but also the service you're getting from the service provider. You can have a very nice hardware solution for Wi-Fi, but if you only have 1 meg with your service provider, you will not feel, that much the difference in terms of speed. Yep.
Okay, thanks, guys. Now, David, just to close off your question, remember, moving from 2.4 to 5 gigahertz frequency is also a device capability. issue, right? Because your devices, both access points and clients, have to support that move or that capability as well. So let's say you have a platform that supports both 2.4 and 5, the access point or the wireless platform. Your clients need to do the same. And you have technologies that can be built into your platform to switch those channels in the event that saturation occurs. So understanding that these things are driven by the requirements of the application, not more so the other way. But I hope I answered, or hope we answered your question. We have a next
Yeah,
question.
there is a question.
Mhm.
There is a question from Nicholas. He
Yes.
says, how about if you deal with a building that has various companies which sharing the same space as our space? How can I eliminate degradation? I just mentioned about a technology called Channel Fly, and this technology will pretty much let your network to use the less saturated channel for your traffic, right? It's like if you are in the highway, Nicholas, and you notice that there is a lot of traffic on the highway. Channel Fly, which is a technology that some wireless providers can offer, wireless hardware providers can offer, is they will find the best lane to move within the highway to make sure your traffic gets faster and better. I don't know
Okay.
if Eric, you have any other comment about it.
Well, yeah. Reduced interference is essential, and you may need a technology that focuses signal to the devices. If in other cases, we can recommend narrow antennas or sector antennas in order to focus the signal to the right position, to the right where the devices are.
Mhm.
So I think that you need to verify your environment, and taking note that reduce interference is essential with all kind of technologies that you can find in the market.
Okay. All right, guys, you have about 8 more minutes. We have some questions. So Nick, what is also important, Nicholas, that is, what is also important to understand, and for everybody in the audience, interference is something that you will get. The better wireless platforms are the ones that help mitigate that interference properly. So interference mitigation is a big game. So interference is not something that you can avoid, but it's how you manage it. So there are different technologies, right? And Nick, we could always go into this further because I know the situation that you are referring to, right? And you could always look at technologies and how Channel Fly could implement it, because there is a learning process for Channel Fly as well when implemented. There's a question again, how close is close before an AP will be affected if installing close to glass? Now, glass does something called, reflection, like it reflects yourself, so it can reflect the signal. Glass creates in an internal environment what is called multipath. So multipath is when you take a signal and throw it all over a particular location. How close do you have to be? My answer would be, as long as the access point can see the glass, then you already potentially causing issues. Now, Eric or Hoy, I don't know if you all have a better answer than that, but glass is something that needs to be managed.
Exactly, it's not about the distance; it's about the physical effect. Like you mentioned, reflection is the problem with glasses. It's not really about the distance. In some case, I don't know how do you say, tinted glass is the level of the reflection of this kind of glass is very hard, and sometimes even if you are next to the glass, you can have any signal, or you can have a performance problems, or it's not about the coverage, it's not about the other thing, is about the physical effect, that reflection that the glass has.
Yeah. And also, I think to maybe complete what Eric said, is also how big is this glass, if you want to say it that way. It is, just keep in mind, access points with high technologies such as Ruckus access points, they use algorithm to move data all around. So I think a direction of traffic, where is people being connected to and from the AP, and where is the glass located, and also the size of the glass, it will determine how much it can affect or not. But going into, maybe, I don't know if I think it was Said who made the question about the glass.
Yes.
If it's for home purpose, if your modem wireless router it's next to your window, my recommendation, if that's where you're coming from, my recommendation is try to move it to another area of the room, and I'm pretty much sure you will have a better performance overall.
No,
Because that's a
Said.
very common
Oh,
mistake at home. I have seen a bunch of
yeah.
homes where they have the wireless router pretty much on the, next to the window, and I'm like, no, you have to remove it. But at the end, it's not about distance. It's about design. Where is the connectivity coming from, and so many other factors, right, that can affect how the reflection on glass can affect Wi-Fi.
And also, Saeed, and I think Derek as well, what you also have to consider is where is that access being requested from? If I'm a
Exactly.
client behind that glass, remember glass reflects and creates multi-part scenarios. We spoke about polarization and diversity. Glass actually changes the polarization of the signal. So that in itself creates a situation where if your client is expecting a horizontally polarized signal, but the glass is reflecting and changing that polarity, you can get data loss. So it also depends on where are you trying to access that access point. So it's a number of factors, not necessarily as important, not necessarily the distance. All right. I have a question. Would you mind shedding some light on hidden node? I need some clarity there, Justin. I don't want to assume, but I think you're talking about hiding an SSID. I'm not sure. So if you can message back, and if we don't have time, we'll definitely get that back out to you and seek the clarity to answer the question. But I don't want to assume and answer the wrong question. So if you can clarify. Now I have another question. Just a few minutes, guys. I purchased access points that are dual band, 2.4 and 5. It does not mean that my client devices within the organization can accommodate both. Absolutely true, Hayden. How does the organization treat with such? To be honest, I don't think the organization has to treat with it. The way mobile phones are changing and devices are changing technology, that is something that more than likely is going to be a natural transition based on technology changes. What is more important in my mind, and guys, you can jump in, what is more important is that the organization has the technology to support that variation
Both.
from 2.4 to 5. The devices and the way consumerization actually is changing, people buying different devices just because they want it, and marketing, that in itself is going to happen. That's the natural transition. But if your organization has the technology, they have just future proofed itself and able to actually deliver the service on both. So at one point, you may not be able to, but as long as the organization is capable of delivering that service and supporting, that is going to happen. Clients are going to change. And it doesn't mean, guys, if you have a 2.4 gigahertz client, that's a bad thing. Understand that the better technologies support both new and legacy. You have to support legacy, right?
Yeah.
Because you have other technologies still relying on that, and legacy performs as well. There are just disadvantages. So, Hayden, I hope I answered the question. The organization, I don't think, has to treat with it. I think they just have to put things in place to support that transition. And by going dual band, they would have done so. Guys, you have anything to add there?
No, I think you pretty much covered it all. Is pretty much as long as the organization supports 2.4 and 5, and the mobile industry is changing every year. We get new phones, new tablets, new technology. So as long as your organization supports both, you should be fine. And I think, and Eric, correct me if I'm wrong, or Sheldon, but to my understanding, at least on a, let's say, enterprise level of access points, your solution in your organization should be able to manage 2.4 or switching to 5, depending on the availability of SSIDs on your network. And also if you're letting your network for devices to switch from one to the other. For example, in Ruckus Unleashed, you just get one SSID and it can go either 2.4 or 5, depending. The system will automatically move you to one or the other depending on your mobile devices capabilities and also on the traffic. So that will be nice for the people who ask if the access points he got are able to do that, because I think the questions came kind of that way.
Yeah, that's correct, Jorge. And we actually did that deployment at Hayden and Day. So yes, you're correct. The SSIDs actually mask the frequency. So
exactly,
one SSID has the capability of bringing 2.4 and 5 because the access points are managed by a controller. So the device and other technologies like band steering and those things will actually decide which is the best frequency to go, whether it holds back the beacons from the 2.4 and pushes, right? So that actually happens automatically, Hayden. But your deployment in particular, if you're referring to organizational deployment, has that capability to support both frequencies, but masked or hidden behind one SSID. So the user is really unaware of which frequency that they connect to.
Right. At the end, for the user, is transparent, right?
Transparent.
You just will flow. Now, I know some low-end technologies or low-end wireless infrastructures do not have the technology to do this. So I think it will be nice, Sheldon, if you can maybe check with the person who asked the question.
Yes,
because
I will.
Maybe
I will
that's
check
the
with you.
issue they are having. They got maybe a not very technologically solution, and maybe they have to do it manually. And I don't know if this is something that they're looking for to automate this transition from 2.4 to 5.
No problem. We're at 11:32, but Justin, I mean, we can hold on to answer this question. You clarify the question with respect to hidden mode to the point where clients not seeing each other transmitting to the AP. How does this affect performance and how could this be rectified? Based on that, I think you're talking about what we call in the Ruckus world client isolation. Client isolation actually stops the ability from each client to hear each other's transaction or see each other's transaction on the same access point.
Yeah.
So how does this affect performance? Client isolation, based on our experience, does not actually affect performance. Like we do that in our deployments in hospitality. We enable client isolation because you want to ensure that the guests are more safe or safer in that type of environment, because wireless again is a shared medium. So we've never seen client isolation. And thanks, Chris. Chris is actually one of our clients, and he has client isolation implemented. So yeah, it has done a lot. So we've never actually seen it affect performance, but we've seen it used as a tool to enhance the experience and actually stop stuff like peer-to-peer networking and so on the wireless platform. So it's actually used to your advantage.
Yeah.
Hope I answered that question. Guys, we are at 11:33. Any other questions that we have in the chat? We'll definitely contact you and ensure that you have an answer. What we like coming out of this is that anything that you guys are still unaware of or need to clarify, we have all your email addresses, but we'll actually want to schedule follow-up meetings and consultations with you guys. We just don't want to stop the webinar right here. We want to continue the learning, and we want to thank you for your time, because we know everyone is busy. Now, we have something special here. Webinar participants on any wireless solution using this promo code Staying Connected, and Jorge, I know you'll start a smile because you will help us do this. We are going to offer special discounts on any wireless solution that you guys may be interested in. And this offer, Jorge, how long can we extend this offer to?
Well, actually, for people participated on this webinar, please feel free to use this code for the next 90 days. So we have about it's February 1st. We have until April.
April,
Am I right?
yeah, April.
Yeah. And
February,
please,
yeah,
yes,
April.
it will be a pleasure to help you using all the topics discussed on this call and make sure you guys have not just a Wi-Fi solution, but the best Wi-Fi solution with the best customer experience. So take advantage of the promo code because we have really, really nice discounts to apply to help you move forward into a high level enterprise wireless solution.
All right, guys, thank you very much. And we'll be reaching out to you. If you have anything that you need, guys, please use the email consultations. You want us to come and look at your network, you're having an issue, we are here for you. This is not going to stop. We're going to keep contacting you guys because we want to build a rapport with you, our customers and potential customers. Jorge, Eric, thank you very much for your time. I know you guys have to go back. Eric, it's very early by you in Mexico, so I know.
Thank you, Sheldon, for this invitation, and for the other people that wants to have a deep knowledge in Wi-Fi technology. I recommend these guys. These books is from CWMP.
I have my copy right here.
This is the Bible of the Wi-Fi technology. This is agnostic vendor that is the best. And yeah, take a look of this documentation. Is very, very good information. And thank you so much, Sheldon, and thank you guys for your time.
There you go. Thank you for the
All right,
invitation,
all right.
Sheldon.
Thank you,
And
guys.
I shall be in Trinidad anytime soon. So hope to see you guys and also some of the people participating on the webinar for sure. Thank you.
Thank you. All right, guys, have a good day. And again, thank you for choosing Blue and thank you for attending the Blue Room session. Take care, guys.
Bye-bye.
Bye.
Thanks. Bye.